Good morning, everybody. You are welcome in the session. I would like to present you today this case study back analysis of a large-scale collapse of chalk mine in France, happened in 1910 with my colleagues. So start with some example of massive or large-scale collapse. What is large-scale collapse? It normally happen very fastly and concern a large surface with discontinuous subsidence. This is what is I define the large-scale collapse, subsidence, or massive. And the question is the consequences of this phenomenon is very, very heavy. As you see in my table, this is not in my paper, but I collected many case studies over the world since 1985 up to now, and you can see the surface, it's in hectare and kilometers. And you can see again in the damage consequences in terms of victims. And we have a number of victims and a number of damages to buildings and infrastructures. So based on this description, I would like to go further in terms of factors of the phenomena. So regarding this hazard, subsidence hazard, geohazard, we have some predisposing factors related to the site. And one of them, the geology, and other of them is the mining geometry, others, material characterization, and triggering factors coming from dynamic, water, climatic change, and others, and others. So we have here summarized the main factors of massive or large-scale. I would like to mention here from the geology aspect three elements. One of them, the stiff beds regarding the other layers, and the tectonic and faults, discontinuities, and the behavior of materials. Now come back to our case study to present this massive sudden collapse of the chalk mine during the climatic event. So the first things to present, as you see in the location of the quarries or mines, chalk mines, we have different of them, and we have all of them except one are collapsed since years. And we are somehow we are lucky to have some information about the one of them 1910 collapse. What is the objective of the presentation? Is to identify clearly the role of the different factors, natural factors and man-made factors, to triggering the catastrophic event at that time, and to learn for this existing carrier or mine still stable. So the question is why we have unstable or large-scale event and we have stable one, and what are the main factors. For people and I will show you later, the main factor is the water. And I believe is not enough to explain large-scale massive collapse. So the question is, why is still existing? Coming to the event, this is the situation of the mine just before the chalk mine, underground mine, and this is just before the event. We can see everything is good, the water is there, and the entrance is there, so no problem with this. And after the heavy rain, we have this large scale collapse here with, it look like landslide. So it look like landslide, large landslide, but we know there are the underground chalk mine. And if we look for the details, we can see here this is the section. We have here somehow the surface of the collapse and the area. We have small pillars here, and you know in this element one parameter, key parameter is the extraction ratio, because it determines the stability of the pillar. And other things we have also, I will go further, the relation, sorry, I will go back, the relation to the channel, the river, and the water interaction. So now the event is happened here in January, and this is the water precipitation. This is the water level in the river, and we see clearly there are something happen, because we have just before very heavy precipitation. It's more or less 25, 27 millimeters during 3-4 days. And we have the increasing of the water level, and some people see in the mine the water rising in the pillars in the mine. So the water is really one major element in the situation. Now, coming to the geology and the geometry, we can see some things and need more investigations. If I come to the geometry, I see clearly there are the slope in this area. And we describe in this area the existing of fold or faults. So there are some discontinuities. And we see also the limestone, comparing the stiffness of the limestone to the chalk material, there are a big difference in terms of strength and in terms of deformability. And if I look for the, again, for the geology aspect, we can see there are some in 3 dimension, also some distribution related to the creation of the valley. So the geology, the geotechnique, and other aspects need to be investigated. So my objective in this presentation and in this study to identify the effect of the cliff, the effect of the fall, and the effect of these stiff materials in the area. So I look to do numerical modeling. So the numerical modeling become after the investigation. What is the main objective? Is to identify the mechanism of the collapse. So in this specific situation, I built different numerical modeling to compare the different behavior of the materials. So taking into account the presence of limestone or not, the presence of fault or not, the presence of cliff or not. So I make some investigation, expert investigation. And you see here the configurations. I did also different aspects. For me, the question of mine is one aspect, but not the main one. I look to the interaction between mine, fault, and a cliff in this question and the geology of materials. Coming to the geology of materials, I said the water plays a role, sure. And we are with chalk materials. And chalk material is very sensitive to water. So we can see here, for example, the parameters taken for the numerical modeling, but you can see the behavior of dry chalk materials and saturated chalk material for this carrier, and we can find them in other area, and we can see the difference of behavior. When we are saturated, we have nothing. The strings drop from 3.5 to 0.8 or something very close, so very, very low. And another aspect, so I take this into account.
Sorry, 3 minutes to conclude.
Right. I will go further. So I am sorry. There are many details, but time is carrying out. So this is the result of numerical modeling. Very quickly, very, very quickly, look to the phases here, and maybe we can look for the this blue one. What is the blue one? Blue one is the tensile stress. Tensile stress, it's mean there are some failure, potential failure. And this is, in the left, you have horizontal stress, and in the right, you have vertical stress. And again, look for the blue area. And we will look for the phase 3 or 4. It's mean when the fault, the strings of the fault decrease by the water effect from 30 degrees to 10 degrees. And we see clearly the presence of tensile stresses, horizontal and vertical, and mean we are able to slide, we are able to move. Very interesting. Coming now to make the mechanism. And this is the question. What happened really from data and from back analysis and numerical modeling? I suggest to build this mechanism for the collapse. I will explain it. We have the mine, we have the cliff, and we have the fault. So we have an unstable mass and very heavy mass. And we have the chalk mine with the small pillars. So this mass, the load of this mass will be applied on the pillars, and the pillars with the water lose the strength. So we have really the mechanism of sliding between the cleave and the fold and the behavior of the chalk pillar. So we built this mechanism related based on the different elements, and we say now for evaluating, assessing the geohazard of mine, we should take into account the different aspects to evaluate clearly the importance of massive large-scale collapse. That's the conclusion. I see that Chairman see it's enough, so I will stop. Thank you very much for your attention.
So if you have any questions about this interesting presentation, okay.
Then are you able to explain why the fifth mines does not collapse based on these results? Thank you.
Yes, for sure, but it's not that there are only one is still stable. Yeah, very, very good question, and we should working in it. So if I have another map, but if you look for this one, you see from the geologic aspect here, back. We have some turn. So we believe the in-situ stress, initial in-situ stress, due to the creation of the valley and the change here, there are more confinement stress to make the stability. Another one, maybe this fault is a different place, because I believe, and the numerical modeling clearly showing this result, the distance of the fault relatively to the cleave play a role to create these tensional stresses or unconfining stresses.
Thank you so much. I think we do not have more time for questions, but you can still ask questions during the break.
Thank you
Please.
very much.